Good morning. So in the yesterday's class, we discussed about displays, controls, workstation, anthropometric data to some extent. So today we'll continue the same. So the use of anthropometric data, why it is required, so how important it is for designing a workstation or the workplace. And we were also discussing about MSD, musculoskeletal disorder, the cause of that, the risk factors involved in that. Okay, before starting this video, so I'll just explain it to you. The anthropometric data, which we have already discussed, and musculoskeletal disorder also we have discussed. In that, anthropometry use of anthropometric data, why we are supposed to collect the anthropometric data, how it is useful in designing the workplace or designing the workstation, that we are supposed to understand first. Before that, what is anthropometry, why we need to study it, where it can be used. So that also we need to understand. The study of human size, maybe height, weight, or whatever, the size of the human body, mobility, shape, need to be studied before designing a workstation or workplace. For the purpose of designing the products as well as physical surroundings is referred to as engineering anthropometry. Engineering anthropometry is the branch or the study of human size, shape, mobility, right? So which is suitable for designing or which is to be considered for designing the workplace or designing the product or physical surroundings. That is referred as engineering anthropometry. This discipline for such studies arose from physical anthropometry, wherein it was necessary to quantify such human physical attributes precisely for comparative purposes. The early industrial engineers realized the potential for the application of these data in the workplace, which motivated the engineering anthropometric field. Anthropometric data relates to measures of various human traits, primarily physical dimensions. It is related to the physical dimension of the human body, right? Of different parts of the human body, weight, range of movement, muscular strength, etc. The substantial amount of such data has been compiled for both sexes, female and male, and for different percentiles for the population. So you are supposed to take the average, the whole population under consideration, or percentile of the population under consideration, male as well as female, and then understand and study the human traits or the human body traits or the size, shape, mobility of the human body before designing a product or before designing a workplace or workstation. This is required. This data includes both static body dimensions, that is a measurement, as well as positions or the movements involved in the human being can do. Okay, that also need to be studied. The dynamic body dimensions, we can say functional body dimensions or dynamic body dimensions, that it measures measurements made while the body members are in motion. That also need to be studied. So this is required to design man-machine system. Man-machine system, as already you know, the ergonomics is the scientific study of man, machine and his environment. We are in the ergonomics, what we are doing is fit the job to the operator or the human being. Fit the job to the operator in the sense make it fit. Make the job fit to the operator. It means that study the environment. Before studying the environment, study the human nature or human body, shape, mobility. All those aspects need to be studied. Based on that, you are going to design either the product, because the product is being used by the human being. Any product is being used by human beings. For example, this is the podium. So the height of the podium, say for example 4 feet maybe. So this is the height of the podium. So if suppose the height of the podium is 3 feet, what happens? So I am the teacher, so I am going to take the lecture or whatever for you. So this is what is the arrangement I need for my lecture delivery. So here what should be the height of the podium? What should be the size of the podium? Suppose if it is 3 feet, what happens? If it is 5 feet, then what happens? So all these things need to be considered. Before that, the average size of the human body, average height, for example, average height of the Indian people or Indian community, right? So maybe first you can divide in that itself. You can divide because as strength wise, as shape wise, everything the female and male we can segregate, and based on that we need to measure the body parts which are being used for doing the work during the process. This is what it is. Okay. Then, as a part of man-machine system, the man has to use the physical facilities. Who is using the physical facilities? The human resource is using the physical resource in the organization, whatever may be the type of the organization. Such as chairs, for example. Who is using the chair? Human being is using the chair. Desks, tables, special clothing, machine tools, machine controls, anything. Knobs, suppose if it is a control system, knobs, switches, right, levers, everything is being used by human being during the process. So how it should be, all these, the design of all these should be made comfortable to the operator who is using it, right, so that his efficiency can be maintained. This is what is the objective of ergonomics as well as study of anthropometry. Study of anthropometry supports the ergonomics. Ergonomics in a sense, it supports to design the man, machine and his environment, designing all this. Then all physical facilities must have satisfactory relationship with physical features of the human being, such as dimensions of the human body, hands, feet, then foot, reach both sitting and standing, right? Yesterday I told you how to sit and our feet should be totally on the floor. Then the fatigue incurred during the work or during the whole day will be less. Then weight, height, etc. in order to make the man-machine system a success. Then mismatch between the physical facilities and human size will result in discomfort, of course. So if there is a mismatch, as I told you, if the height of this table is 5 feet, then also I will feel uncomfortable for seeing the whatever laptop or whatever using the notes, whatever. It is very difficult for me. Or even if it is 3 feet, then again I will have to bend and I will have to study this, or I will have to read this, or I will have to refer this. This is how it is. So this is called misfit or mismatch. So mismatch between the physical facilities and human size will result in discomfort and fatigue, and hence a decline in productivity, with resulting low productivity. So everything goes. The objective of every organization is to improve the productivity, increase the productivity of the organization. So by doing this, if the efficiency of the person or human being is decreasing, definitely it will affect the productivity of the organization. To a worker doing assembly type of operation, for example, if he is sitting on a stool or height or whatever, then what should be the height of the chair, whether he is sitting or standing, how he is doing the job, right? What is the workplace layout, where the components are being kept, how they are arranged, everything need to be studied. Then only he can do it in a proper way according to the dimension of the human being, according to the body dimensions of the human being, right? Then anthropometric data or human dimensions of the standing adult male. Clearly, such data are useful and are necessary for the design of man-machine interfaces and workstations. If these are to be compatible with the physical characteristics of the potential user population who is using it. So potential user population need to be considered based on average height, average body measurements need to be considered while designing the workplace. Then this is about the anthropometric data. So just a minute. video, they have shown how the perfect desk need to be designed. So you can see that ergonomics are important at the workspace setup. This is the monitor. So you can see that where the monitor need to be kept, in how it should be kept. Exactly in front of top of the monitor should be 2 inch or 3 inch above the seated eye level. Then use the books if needed. Sit about an arm's length away, that is shown there. You shouldn't have to squint eyes. Adjust the pixel size if the things are not read properly, or use apps. The screen too harsh, then make the adjustment of the screen at 60 degrees downward. Viewing the angle should not go below 60 degrees. Then this is the chair. Push the hips back, adjust the seat height, and your feet should go totally on the floor. Knee should be clear front of seat. Make sure back is properly supported. Adjust the armrest so the arms are relaxed and parallel to the keyboard. Be sure to rock. Keyboards and mouse, how to keep. Use the wrist guard to compensate. Trackballs are a good alternative. See, you can see that the angle 110 degrees between the forearm and the upper arm. If you need to sit forward, tilt the keyboard like this, so the strain on the wrist and the fingers will be less. This is the perfect view. Once again they are showing. This is very, very important because it is in your syllabus, it is mentioned that the design of the keyboard, design of the desk, computer desk. So now you can see, just now I have explained what is anthropometry, how anthropometry data is important, why we need to understand it. The same you are going to see here. What is anthropometry, how it is related to ergonomics. Please watch this.
Often involving research into measurements relating to people. It also involves collecting statistics about the human body. results. If a designer takes these measurements and applies them to a product, to make the product easier to use or more comfortable, this is called ergonomics. This animation shows how anthropometric data has been applied to a computer work area. The comfortable seating height has been determined by collecting the measurements of a wide range of people. A designer has then used the measurements to ergonomically design an adjustable chair. This is a chair that is comfortable to use and works well in its environment. The same system of collecting measurements and applying them to a product is seen with the office table. It is the correct width, which means the user does not need to stretch. Also, the monitor has been designed using data or measurements, so that it is at the right, comfortable height for the user. This is another example of anthropometrics being applied to a product. When designing a chair, one of the most important factors is comfort. This is linked closely to the seating height. Usually, the seating height is calculated by measuring the most comfortable height for the person who is going to use the chair. If the chair is to be used by numerous people, such as in a doctor's waiting room, it is important to measure the comfortable seating height of a range of people, and then work out the average height. The average seating height is then applied to the chair, which should result in an ergonomically designed chair, one that suits a range of people. Try this simple class exercise. Imagine that you are designing an electronic device for pupils of your age. The device is the type that will be picked up and handled. This means that it is important to collect measurements relating to the size of the hand. This means collecting anthropometric data. Look at the diagram of the hand. 2 dimensions are shown on the hand. Measure your hand and write the dimensions at the top of a table of results. Use millimeters. Then collect the measurements of all other pupils in the class. Work out the total of columns, and then work out the average of each. The average dimensions or measurements are important because the size of the electronic device could be based on these. When manufactured, the device can be said to be ergonomically designed. This design sheet shows how anthropometric data can be displayed. A number of measurements have been collected and written into a table of results. Simple diagrams clearly show the different measurements, and the reasons for their inclusion is in the text. For more information and exercises on anthropometrics and ergonomics, go to the links shown on the screen.
Welcome to Human Factors in the Built Environment. This is Chapter 2. Today we'll be talking about anthropometrics, part of human factors. We're going to understand what the term means, and it means about measurements of the human body, especially in the relationship to the various activities that humans do. We're going to understand how age and cultural difference factors into anthropometrics, and why it's important to study this. So we have 2 kinds of dimensions, anthropometric data. One is structural or static dimensions, and this is where someone is...
So whatever I have explained about the anthropometric data, whether it is a static or whether it is dynamic and everything, that is shown in this video. Just observe this.
We're going to understand what the term means, and it means about measurements of the human body, especially in the relationship to the various activities that humans do. We're going to understand how age and cultural difference factors into anthropometrics, and why it's important to study this. So we have 2 kinds of dimensions, anthropometric data. One is structural or static dimensions, and this is where someone is standing tall with their weight equally distributed and their fingers are straight. And that's our classic anthropometric data that we take, but we also take dynamic dimensions where the body is working in a specific task. It's important that the interior designer consider body sizes of those using the space. Here we're going to look at several different classifications. The first being the average of the U.S. population, the anthropometric data that we see here. On the low side is the 5th percentile, and on the high side is the 95th percentile. And right in the middle is the 50th percentile. And while it may be true in other areas where 95% of 100 would be great to have, that's not serving 95% of the population. That's serving a very small area of the population. The major part of the population, or the average person, is in the 50th percentile. Now, the military would be being updated. Here's some critical dimensions. We can see that the range of, if we just take the first line on the standing height.
So this shows the anthropometric chart which select anthropometric features for an average adult. Okay, this is the survey, or this is the average.
On the low side, in the 5% category, a male may be 63.6 inches tall, whereas on the high side, in the 95 percentile, he might be 6 feet or 72.3 inches. And we can see the average male, therefore, is in the center at 68.3 inches or 5 feet 8 inches and a third. And then we can see the female on the other side is generally smaller overall than the man in every category. And this could have to do with hormones or evolution, and perhaps this is going to change over time as humans have been evolving. Here's some other critical dimensions and some definitions of what these areas are. And you can look on the charts and the diagrams that we have later and compare these. And of course, our height, our sitting height, our knee height, but more specifically the popliteal height, which is the area or the distance behind our knee or underneath our knee. Here are 8 dimensions or 8 measurements that I, as a designer, use very often. And here's the popliteal height and the depth we can see on the seated position. That's underneath the knee, and from the back to the front underneath the knee. The seat breadth, or the width of that a person occupies, is often undercalculated, of course. And we have shoulder height and shoulder width, actually, and elbow height and our elbow width when our arms are out. And that is what I call elbow room. Here's some of our classifications. We can see on the left side, the maximum body breadth, the sidearm reach, the thumb to reach, the maximum body depth, the popliteal height, again, the knee height is different than that, and that gives us our thigh clearance, which is another area that designers often need to understand between a countertop and the chair that's sitting in the area so that we can clear there comfortably. Here we can see the differences among children, that between 0 and 3 years, we have a lot of growth of at least 2/3 of the size increase. And then 4 to 10 years, the growth slows down a little bit, but significant changes if you look at, that you might have started out when you were 21 inches, and by 10 years old, you're 54 inches. That's a pretty dramatic difference. And then we can see 11 to 18 years and on up into the teenage years, we begin to reach our adult height, although some people don't reach their full height until they're in their 20s. That there is an 8.7-inch difference between the average shorter man and the average taller man, the 5th and the 95th percentiles. So average, as I've mentioned before, is 5'8" and a third. Here we see women, and the height difference, instead of being 8.7 inches, is 8.1. So little less difference between the shortest and the tallest. So of course a designer wants to consider all people, and you can see right in the middle there, we have this max comfortable range that begins to take care of people in a wheelchair, a very tall person, if we consider their clearance, a woman that's much shorter, and a variety of people. Intra-individual as I mentioned before, when you're a child, you may start out at 21 inches, but you may end up at 71 inches, which is quite a lot of growth, a growth of 50 inches over your lifetime. Our needs change over our own lifetime. But between gender and culture or heritage or ethnicity, we also have differences, size differences. And then we also have generational variability. And this means, for instance, that we evolving because of better food and better health. This generation is larger than the generation before. We can see quite a significant change over hundreds of years since we've been studying human dimensions. There was even a study done among white, black, and Japanese, and we could see some of the average differences that we have with people of a smaller stature and perhaps someone from Africa being of a taller stature. And we can see that there's quite a big difference in just the leg length alone. There's websites for everything these days. We look to the right, we can see that the 10 tallest countries, this is not counting actually any in Africa, but of the European nations, we can see that people from the Netherlands are among the tallest. This map kind of gives you a colorful array to see where that the taller people are in the very northern areas. And here we can see there's even an averageheight.co website, and the tallest man being from the Netherlands, standing at 6 feet, the shortest from Indonesia at 5.2. And then we can see the women are smaller across the board as well. Now, this doesn't mean that people have been mixed across the globe and that we need to consider as designers from person to person whom we are designing for. Here we can see some of the ways that a designer applies anthropometric data. For instance, if we look at our clearance, which is the second line down, the space needed to maneuver, and we think in terms of someone making their bed, we're going to think that if we have an adequate clearance, if you, for instance, had a bed that was placed under these different constraints, understand that they do apply to designers, and these are the ways that we can help people by giving them proper clearances in order to be able to move.
So in this slide, so I'll just explain that. The constraints that may affect the criteria are human body measurements, for example, leg room, elbow rooms, circulation, access. So what are the primary criteria for that? Comfort, efficiency, safety, accessibility, and aesthetics. These are the 5 primary criteria. With this, what we need to achieve or objective of that, ease of the movement. Ease of the movement, appropriate special needs, then develop the obstruction, right? And inclusive design look, everything, right? And then clearance space needed to the man who is working on that, that is comfort, efficiency, again same, safety, accessibility, aesthetic criteria, then reach or the grasp, hold, right? So together the primary criteria for human body as well as the clearance space is one and the same, and then for reach or grasp, this easy to manipulate the controls, easy to open the doors, drawers, no obstruction to reach, easy to access the controls, then appropriate to design concept. All these things are the objective or the space to be given to the worker so that he can work comfortably and efficiently. This is what it is. Then posture may relate to the chairs or the access to dresser drawers within the space. So again, all these are the constraints that are there. So what should be the posture to take the drawer out or to put it inside? This is how they think. They use the anthropometric data, whatever the body measurements, as we have seen. For the children, it is different. For the adults, it will be different, and it is also based on the average height of the human being or the male as well as female in different countries will be different. So they collect the data, that is nothing but anthropometric data, which is being used to design the workstation or workplace. So this is what it is, workspace. What is importance of principle? The most important item should be in the most accessible location. So it means that the importance of the important principle of workspace is the item should be accessible in the workstation to the person who is using it. This is what it is. Then frequency of use principle. The most frequently used item should be in the most accessible locations. Continuously, if I am using it, then it should be easily accessible and readily accessible, comfortably accessible to the person who is using it. Then function principle. Items with a similar functions should be grouped together. Then sequence of use principle. Items are commonly used in sequence should be laid in the proper sequence so that there is no need of searching for the object. Why? Suppose if this is the repetitive short duration type of operation, assembly type of operation, then you make the compartments or you make the bins in such a way that, okay, already you have studied in industrial engineering the principle of motion economy, how to design the layout and all, how to design the workplace layout and all. In that you are going to arrange all the components in sequence in which they are being used for assembly type of operation, okay, in a proper bin, so that there is no need for the worker or the human being to search for the object. Continuously he is doing, without his attention he can pick the components and do the assembly type of operation. So this is about the seating arrangement. Already you have seen number of times. Then okay. So this is about the anthropometric data, how the anthropometric data is being used, right, while designing the workplace. So how it is need to be analyzed, okay. Then how it is to be taken, right, how the dimensions need to be measured, and how much important it is that we have studied today. So with this we will stop. So tomorrow we'll start with working environment or design of the workplace layout. Thank you.